Welcome back, everyone. We're going to do another example with a one sample t-test. This one is really fun. I hope that you enjoy it as much as I do. So we're going to take some existing research and modify it. So there is research on whether or not newborns prefer to look at attractive faces compared to less attractive faces. So we're going to assume that a sample of 9 infants were selected to participate in our study. And those 9 infants were shown attractive and unattractive faces side by side until a total of 20 seconds had passed, and the number of seconds looking at the attractive faces was recorded. So this is an actual study. So here is the data. The mean of our 9 babies was 13 seconds spent looking at the attractive faces. And we had a sums of squares for our group of 72. We're going to need this for later. We're going to use a two-tailed test with the alpha of 0.05. to determine whether babies prefer attractive faces. Okay, so we're gonna work this out with first trying to figure out what is the information that we need. So the critical data that we need to know is our N of 9, our mean of 13, but we also need to know the population mean. Well, what is the population in this case? Well, actually, I'm gonna give you a little hint about this. Our population mean is 10. And the reason why it's 10 is because in the study, the babies were given 20 minutes to look at, or I'm sorry, 20 seconds to look at the pictures. So if the babies are looking equally at each picture, 20 divided by 2 is 10. So 10 is the null hypothesis. It's what we expect. We expect that the babies are going to spend equal time on both of those images. And so that's why the population mean is actually 10. It's not that babies all over the world, the average is 10, but rather that if there is no difference between the attractive faces and the unattractive faces, then the baby should be spending 10 seconds on each, okay? All right, so first step is to set up our hypotheses. So we're just quickly gonna say that the null hypothesis is that our mean is equal to the population mean, or that the mean is equal to 10. And the alternative hypothesis is that our mean is not equal to the population mean, or the population mean is not equal to 10. So that's pretty easy. Let's go on to step 2. So in determining our critical region, we have to look at our alpha level of 0.05 in a two-tailed test. If you look at your t-table, that equals a t of 2.30. So 2.30 is going to be the t that we're going to evaluate our observed t against. So let's take a look at calculating our observed t. Okay, for this next step, I went ahead and put all the calculations that we're going to need to be able to perform this t-test. So we have the t formula. We have our formula for the standard error of the mean, which is part of the t formula. But to get to the standard error of the mean, we also need our sample variance. And so we're going to start at the point of sample variance. It's the sums of squares divided by n over 1. So our sums of squares were 72, and that's divided by 8. So our variance is going to be 9. And our standard error is the square root of our variance divided by our n. So our standard error in this case is the square root of 1, which is going to be 1. So we have everything now that we need to be able to figure out our t-statistic. So our sample mean was 13, and the population mean is 10. We're going to divide that by our standard error of 1. So we have a t of 3. So that is what we're going to evaluate against the preset alpha, or the preset t value that we found of 2.3. 3 is more extreme than 2.3, so we're going to reject the null hypothesis. Babies don't spend an equal time looking at both faces. So as you can see, we're going to reject the null hypothesis. There is a statistically significant difference in the amount of time infants spent looking at attractive faces. And again, note how this is written with t, with the 8 in parentheses for the degrees of freedom, equals our observed t, or our calculated t, of 3.00, and our p is less than 0.05. The probability is less than 5% that we would find our sample mean if the null hypothesis were true. So in other words, our preset alpha was 0.05, And in fact, because our t was in the critical region, we say the probability was less than 0.05 that you would find our mean if the null hypothesis were true. And this leads us to reject the null hypothesis. In the next video, we're going to talk about a really important aspect of t-testing, and that is effect size.